So I started saying that one of the things I needed to do was think of a clever way to control Tutorialebot, and there are a number of problems. One of the first problems is the fact that Tutorialebot is a circle or a circular robot, and it's got 3 sets of the omnidirectional wheels on the actual robot. Then in between each of those it's got an IR sensor, and then in between each of those it's got a sonar sensor. Which is plenty of sensors, but it does present a problem because although we've decided that we know that that's the front by putting a nice big arrow on there, and to go forward we switch on those 2 motors, and that will take it forward, and then just dragging this one on as nothing more than a drag motor. I'm not going to get into the complexities of steering with this motor, although that's possible. Initially I'm just going to look at the fact that we are initially going to go in 3 directions. No, we're not going to go in that direction. We're going to go in 3 directions. Oh dearie me, trying to draw an arrow at an angle. Oh good grief, get your spatial equalities going. And so potentially go in 3 directions based on the idea of 2 motors running at any one time, and the 3rd motor, which the nice part about the omnidirectional motor is you can go in a direction, and so why not? Let's actually see if we can actually build a control that does that. So how do we then turn that into simplistic code without trying to put all sorts of AI in it and trying to find a simple way to do it? Now then, one of the problems we know is that much as processors are nice clever little units, when you've got an array, all you've got is a series of boxes, literally one after another, and what I've done is, let's see will this work out yet. I've put the front sensor in the middle box, which, as I said, it was row 5. I showed it was row 5. I sort of half predicted I was potentially going to do this. Then 2 further sensors away I've got the second infrared, so that's an infrared control, that's an infrared control, and then that's an infrared control. So between each of the infrareds are the sonars, so that what you've got is that's a sonar, that's a sonar, that's a sonar, that's a sonar, and those are sonars. So again, then in between each one of those you've actually got a wheel, and then right on the outside you've actually got the same wheel. And I need to bring the camera back on. So although what we've got there is the limit of what the system can do, what we've done is we've effectively defined that circle as a flat plane. And so my thinking is that why does it need to, it doesn't need to know it's a circle. All it needs to do is react to that flat plane based on the information that's coming in. And part of the way that I've set it out means that as the data's coming into this array, that can decide where it decides to put the power. So let's assume that we're going in that direction. So this theoretically, the infrared is going to see the obstruction first. But equally, if the obstruction was offered aside, again relying for the fact that what we're doing is we're looking this flat wrapping round our circle, it equally, there could be an obstacle that it's going to run into there or run into there, which means that the information is going to be coming in to these sensors here that are actually sat on the either side of the wheel, because you could be going in, running to bump something. Equally, you could be any one of those three sensors at the front, but it is going to, by nature of the fact that we're going in that direction, it is going to be in the sensors around the direction that we're going in. So, assuming that these sensors are starting to feel something arriving, we know to slow that wheel down, because in reality that will or do we know? Do we? This is where again, see, thinking of these in 3D. I'm doing this on the hop in front of you. Do we actually want to speed that wheel up? Because allowing for the fact that these wheels are turning in that, they're turning towards each other, so that we're actually grabbing ground going forward using the omnidirectional thing, and they're turning towards each other. If this one speeds up, will it then vector it away from the obstacle, assuming that you want to keep going forward? So that what you're doing then is you're effectively using the increasing or the decreasing numbers in there as the object gets closer to speed that motor up. In the same breath, if it's a flat wall, then all of those will increase. It will be decreasing as it gets closer, so we can slow both wheels down. Or could we, and that's the thing. Do we speed? If we speed them up, we're vectoring away. If we slow them down, so this is where we need to sit down and think about as logics. So you can see I'm sort of halfway there, and I thought I'll do you an update so you can see the thinking, see the process. How I'm thinking that if we turn that into, and that being where the joint is, if we turn that into a flat surface, is it reasonably easy to actually, and what rules do we need to come up with to be able to make that flat surface look like it's thinking as a three-dimensional or a two-dimensional solution? Because if you think about it, that as things are going. So, another quick update. I wanted to try to start with something, but you can see how by using the simplistics of an array and thinking about how I put the sensors in between the wheels and where the wheels are, how I can sit down and look at the logics of how I deal with each of the wheels. Again, allowing for the fact that that is actually one wheel, so that whatever I do with that, I do with that. And then balancing out what these sensors are doing with how I then react to those wheels. But of course, the sensors are directly related to the positions based on them being put in the array the way they have been. I don't know if that seems obvious, or whether I think I'm thinking of something clever. But anyway, we'll see about turning that into code, and that's today's update.